Welcome back to our lecture about numerical differentiation. And now we will continue about second derivative. And here we have 4 formula that you can use in your exam or in your test too. And the procedure is same. Here we call it 3-point formula forward difference here. Let me change here. Alright, here we call it the 3-point forward difference formula because here we use 1 point, 2 point, and 3 point, and the rest is same. And we also have 5-point central difference formula because we use 5 points: 1, 2, 3, 4, and 5 to find the second derivative. And how we find this formula, we also can derive as usual by using the Taylor series expansion about a point: x plus h or x minus h, x plus 2h, x minus 2h. But you don't need to worry about that one. You only need to know how to use it. And now let's discuss about this example. Again, this is the continuation. Actually, it is a continuation from the previous example 1. You have all of this formula value or data, and you need to find the second derivative at point 2.0. And the question here asks you to use 5-point central difference formula, which is this one. So you just write back what is the formula for 5-point central difference formula, and it is given by f double prime x approximate 1 over 12 h square, and then everything you must multiply by minus fx plus 2h plus 16 fx plus h minus 30 fx plus 16 fx minus h minus fx minus 2h. And here I can say that I think we will use all this point: 1, 2, 3, 4, and 5, all the values. And our h is 0.1, so that here is equal to 1 over 12 multiplied by 0.1 square, and then negative f, and then here you have 2.2 because 2 multiplied by h, and then plus 16 f 2.1 minus 30 f 2.0 plus 16 f 1.9 minus f 1.8. And then you just substitute everything. You get is equal to 1 over 12 0.1 square, and then minus f2.2 is 19.8550 plus 16 multiplied by 17.1489, and then minus 30 multiplied by 14.7781, and plus 16 multiplied by 12.7032, and minus 10.8 0.894, and you substitute all this number in your calculator, and what you will get is 29.3017. And as usual, you also can find the absolute error, but of course here what you need to find is you need to find the second derivative of your function, where the second derivative, I think here, is given by x exponent x plus 2 exponent x, and so this one implies f double prime at 2.0 is equal to 2 exponent 2 plus 2 exponent 2, and what you will get is 29.5562. And then for the absolute error, so I write it here, absolute error is equal to, the exact value is 29.5562 minus 29.3017, and you will get 0.2545. That's it. This is the answer for the, and this is the absolute error. And we also can see here, the next example is about a distance of a rocket was timed during launching, where y is the distance from the Earth's surface. And then they ask you estimate the velocity v, which is dy dt, and then also the acceleration a dv dt for that rocket when t equal to 3 seconds by using 5-point different formula. So 5-point different formula is given by, I think this one, what you need to do is you have 5-point different formula. So of course this one, to get your v, we need to use the formula in the first derivative, and to get your acceleration here, we need to use the formula for the second derivative. So what you need to do is first find the first derivative, which is v is equal to y prime t, and the formula is equal to, I think, 1 over, if you look at your formula, is 1 over 12h minus y t plus 2h, and then plus 8 multiplied by y t plus h minus 8 y t minus h plus y t minus 2h. So this one, to find what is the velocity, and to find what is your a, the acceleration a, also is equal to y double prime t, the second derivative, and you need to use the 5-point difference formula. It is given by 1 over 12h square minus y t plus 2h plus 16 y t plus h minus 30 y t plus 16 y t minus h minus y t minus 2h. And then you know that our h now is 1. Our h is 1 because here the difference between here is 1. H is 1, here is h is 1, h here is 1. So that's why our h is 1, and then you just substitute all the value and then you will get the answer. And I think the last answer what you can get is the velocity is given is equal to 12 meter per second, while your acceleration is 4 meter per second square. So this is about the second derivative, how to use or how to find the second derivative if you have data at discrete point. So meaning you just use the formula to find the derivative. So I think this example also is same. Data is given, but this one is about rotating in a plane, a road rotating in a plane, and then you need to find the angular velocity d theta over dt at t.6 using 3-point central formula and 5-point difference formula with h 0.2. And then the second one, you need to find the acceleration, angular acceleration at t, again at the same point, t at 0.6 using 3-point central difference and also 5-point different formula with h 0.2. And I leave it this one as your assignment 4.1, because this is a chapter 4, so 4.1. So of course it is due today, due at 23:59 in the night. Okay, and of course you just need to submit a PDF to me, and then try to do. I think it is easy, but you need to remember we have a 3-point central difference formula. You need to find the first derivative, 5-point, and also same for this one. You have 4. Okay, so that's all for now. Thank you very much for your attention. Assalamualaikum warahmatullahi wabarakatuh, and thank you very much.